Hello. Welcome to my channel. In this video we are going to solve two exercises on the parabola. They will be exercises on the parabola with axis parallel to the y-axis. So we have written the equation of this kind of parabola, and the formulas for vertex, focus, directrix and axis. In the first exercise it's required to calculate the equation of a parabola that passes through 3 points. The point A, B and C whose coordinates are written on the screen. Furthermore, we want to calculate the coordinates of vertex and focus, and the equations of axis and directrix. We put the coordinates of the points in the equation of the parabola, and we obtain a system of 3 equations in 3 unknowns. From the first equation we get C equals 2 minus A minus B. Then we substitute this value of C in the other 2 equations, obtaining a system of 2 equations in 2 unknowns. From the second equation we isolate the variable B. That is equal to 1/2 minus 3 times A. We put it in the first equation, and we can get the value of A. That is minus 1/4. Once we have found out the value of A, we can first calculate the value of B, and then the value of C. It yields B equals 1/2 plus 3/4. That is 5/4. Then using the values of A and B we obtain that C equals 2 plus 1/4 minus 5/4. That is 1. Therefore the equation of our parabola is y equals minus 1/4 times x squared plus 5/4 times x plus 1. We still have to calculate the coordinates of vertex and focus. Firstly we calculate the value of delta. That is b squared minus 4ac. After we have substitute the numbers, we get that delta equals 41/16. Now we calculate the ratio minus b over 2 times a. That is equal to 5/2. The ratio minus delta over 4 times a is equal to 41/16. Then we find that 1 minus delta over 4 times a is worth 25/16. At this point we can write the coordinates of vertex, 5/2 and 41/16, and focus, 5/2 and 25/16. The equation of the axis is x equals 5/2. Eventually we need to calculate the equation of the directrix. Therefore the quantity minus 1 minus delta over 4 times a. The equation is y equals 57/16. We can draw the parabola with focus, vertex, axis and directrix. It is concave downward because the coefficient a is negative, while the parabolas with a positive are concave upward. Let's move to the second exercise. We have the quadratic equation y equals k times x squared plus k minus 1 times x plus 1/4 k. Varying the value of k. We have different parabolas. Firstly, we want to find the value of k, for which the corresponding parabola has the vertex at x equals 1. Furthermore, we want to know the value of the ordinate of the vertex. For that value of k, let's get started. We know that the abscissa of the vertex of a parabola is equal to minus b over 2 times a. From the equation we know that b equals k minus 1. And a equals k. Therefore xv equals 1 minus k over 2 times k. This quantity must be equal to 1. So we get that 1 minus k equals 2 times k. Therefore k equals 1/3. Now we want to calculate the value of the ordinate of the vertex. We calculate delta as a function of k. Then the ordinate that is equal to minus delta over 4 times a. Eventually we substitute k equals 1/3. And we get yv equals minus 1/4. We haven't finished yet. Eventually we want to find the value of k for which the parabola is tangent to the line y equals x minus 3, and the coordinates of the point of tangency. In order to do it, we construct the system with the equation of the parabolas and the equation of the line. We equate the two right terms, and we get a second-degree equation in x. We are looking for the tangent line, so the discriminant of the equation must be null. We obtain an equation where the terms k squared cancel each other out. Therefore a first-degree equation in k. The solution is k equals 1/4. To calculate the coordinates of the point of tangency, we solve the system on the left, putting k equals 1/4 in the first equation. It yields the second-degree equation written down on the left. We can simplify it by multiplying by 4, getting the equation x squared minus 7 times x plus 49/4. I have written on the screen the formula for solving a second-degree equation. Anyway, we already know that delta b squared minus 4 times ac is 0, because the line is tangent to the parabola. Therefore the solution is trivially minus b over 2 times a. In our case x equals 7/2. The ordinate of the point of tangency can be found either by placing the value of the x just obtained in the equation of the parabola, or in the equation of the line. If we are smart, we put it in the equation of the line, getting easily y equals 1/2. From the family of parabolas y equals k times x squared plus k minus 1 times x plus 1/4 k, we have found out that the parabolas with k equals 1/4 is tangent to the line y equals x minus 3. The point of tangency t has coordinates 7/2 and 1/2. We can see the graph of the parabola and the tangent line, with the point of tangency that has the coordinates we had found. Then, colored in dark blue, the parabola with k equals 1/3, that we have seen in the first part of the exercise. The vertex is the point in red, with the coordinates we had calculated, 1 and minus 1/4. Well, this video is over. If you like my videos, you can subscribe to the channel. See you soon with another video. Bye.